Hello everyone. In this exercise, I will explain to you the data normalization by taking this example, the invoice example. I will start by converting this table into the first normal form. In order to do that, we need to remove multi-valid attribute. And then once it's in the first normal form, we need to remove uh, all partial dependency. But in order to remove the partial dependency, we need to firstly identify the functional dependency, identify what are the primary keys, and then identify the full functional dependency and what are the partial functional dependency. And then will convert the table into the relation into the second normal form. And then after that, I need to identify transitive dependency. Then I will be able to transfer this relation into the third normal form. So I'll take you step by step into this process. Starting from step 1, so I already done that. I already converted the table. I'm just gonna copy it here for you. So I brought the table that is already converted ready. You can see that in this example here, I have to make every row has all the data listed. In this case, it was all depending, like row 1, 2, and 3 was all depending on one order ID number and date and customer ID, customer name, and address. In order to remove the multi-valid attribute, all these multi-valid attributes relying on one, and then I have to return all the data. So you can see that all the data are currently, there's no multi-valid attribute and unique rows. So all the rows are unique, and this is what make the data or the relation into the first normal form. So you need to do that. If it's already in the first normal form, you just have to say that the data is already, the relation is already in the first normal form, and then you simply start with the other task. So the other task is giving the specific example of where the three anomalies occur in this relation. So what are the problems that will occur to this type of relation? So there are mainly three problems or three anomalies. These are mainly update, insert, and delete. What does that mean? So if I want to update the price for, let's say, this product ID number 4, product ID number 4. If I update that here, and I did not update this one here, then you will come across issue with the system. So this is one of the issue. Insertion. So if you add a new product, for example, if I add a new product that has product, for example, number 8, product ID, then I need to enter the customer address, the customer name, the customer ID, order date, order ID, which does not make sense. The third issue is the delete. So if you wanted to delete, for example, this pricing here, the 650, then this one will remain. If you delete one ID here, and then you will still have another ID here. So all information about the product is going to get lost. And this is one of the issues that's why we need to do the data normalization and go to the third normal form. So now we're done with converting in the first normal form, but we will have better understanding about that very soon. So these are the three issues that will occur. Now I'm moving to functional, identify all functional dependency. So when we identify the functional dependency, we need to follow the standards. So what are the standards? Like the value of one attribute, for example, the value of this attribute here will determine the value of the order date, and then it will determine the value of customer ID. And you can see it determined this one, and you can see it's 2, it is the same date, 2, the same date. So order ID can determine order date, customer ID. And then you can see it's also determining the name, because you cannot have two names. And then customer, and then you have to argue that. It's based on the argument. If the person or the customer, in some cases that they need to have two names, then the system has to be updated based on that. Customer address, it could be also changed, but in our case, we will wanted to argue that this customer address is also going to be determined by what we can see. It's all the same for this order, and it's all the same for this order. If I move to the product ID, you can see this order ID and this product ID and this order ID and this product IDs are different. Again, the product description, finish is different, and all of them are currently different. Even the order quantity, you can see 2, this one 1006, 1006, 1006, and then you can see that is 1 here, which cannot be determined by the order. So what I'm going to do, I'm going to start writing that. So order ID, I'm just going to bold this one and make it blue. So the order ID will determine the customer ID. It's first going to determine the order date and then customer ID, then customer name. It will also determine the customer address. Okay, so it will determine the customer name, order date, and customer address. So that's the first one. What about the order date? Does the order date determine? So order date generally not determine anything by itself. It's very hard. So what about the customer ID? So the customer ID, it can help in determine the customer name, customer address. Can it determine the product ID? No, you can see it's different. So the second one is the customer ID, which will determine I'm just going to copy that, customer name and customer address. And then customer name is not really going to determine anything, because it's not unique, because could be two customers has the same name, but different customer ID. Customer address is the same, could be two people under two addresses, or two customers under two addresses, but they have two different customer ID. Product descriptions. So product ID, now I need to work on the product ID. So product ID can help to determine the product description. You can see 7 product ID and this product description. You can see 4 entertainment center, So product ID will determine. So product ID will determine product description, description. It will also determine the product finish, and it will also determine the product standard price. Okay, does the product ID determine because you can see the product 7 or product 4 has the same price as the product ID 4. But if you look into the quantity or order quantity, you can see that product ID 4 has 1 quantity and this one has 3 quantities. So I'm not taking the order quantity. Okay. Now, does the product quantity determine something? No, it's not going to determine anything by itself. So what about the order quantity now? So in order to identify the order quantity, an order usually contains many different products, and each distinct product on that order appears as one line, which it is on quantity, and it's often the on unit price, discount, whatever, and etc. So we need to identify what IDs that could help to determine the order quantity. And this is basically for the order quantity, we will need to know the product ID and also the order ID. So if I know the product ID, I will know all these inputs. And if I know the the order ID, I will be able to know the order date, customer ID, customer name, and customer address. So basically, what I'm going to do is that I have to say the pair of order ID and product ID are going to be uniquely identified each one of these order lines. So this is going to be written by that. So the order ID and the product ID is going to determine, they both going to be determine the quantity order. Alright, so now I identify all the functional dependency. So based on that, it will help us to identify what are the primary keys in the second in the fifth question. So I need to identify what is the primary key. And to identify the primary key, we need to look into the functional dependencies and locate the determinants that do not appear on the right hand. So if you can see order ID, if the order ID appear on the left and on the right, then this is not going to be a primary key. We can see, for example, does order ID appear at any of the right sides? No. So one of the primary key is going to be the so I'll just start a new page. So order ID. What is else going to determine the primary key for this relation? Customer ID, you can see that customer IDs appeared on the left and on the right, so this is not going to be a primary key. Product ID, it appeared on the left, but it did not appear on the right, which is going to be the second primary key. So basically, this is also, in this case, it's going to be relating to what identify the order quantity. Product ID. So in some cases, if you are unable to identify what the quantity order depending on, then you can identify the primary key, and then you can get back into this one, because you can just add leave the quantity and then use this formula to identify the primary keys. So these are the primary keys. Next, we need to create the relational model of the table in the first normal form. So we already done the first normal form, but I'm just going, this is table now, but I wanted to do the relation. And as we mentioned, relation is when you map all this relation. So I need to move to the Draw app. And as you can see, I have already mapped this. I just deleted the rows. This one is in the first normal form now. So in your case, maybe you just need to copy this or copy the whole screen and then just place it into six. So this is the first normal form. So now I need to identify full functional dependency. So how to identify full functional dependency? So full functional dependency is, you got here, this one here, the order quantity. So this one is fully functional on two primary keys. So order ID, for example, cannot separately identify the order quantity alone, and also the product ID cannot identify the order quantity. In this case, you need two keys to identify the order quantity. So what I'm going to do now, I need to show that in the relation. So what are the full dependency? In this case, the full dependency are these. Okay, can just shift this one here. So this is the full dependency in your case, and this is going to be, as we mentioned, this is going to be the primary key, which I has to bold and underline, and this is the other primary key. All right, so we identify what are the full functional dependencies. Now I need to identify, in the second step, I need to identify all partial functional dependency. So where is the question? So I need to put this one here. So this is your full functional dependency. Now I need to identify all partial functional dependency. So in order to do that, a partial functional dependency occur when non-key attribute depend on only part of the primary key, not the whole primary key. So what does that mean? So an attribute determined by, for example, an attribute determined by the order ID alone, an attribute determined by product ID alone. So this is, we need to map this now. I'll explain that for you. So I'll start with the order ID. So an order ID is part of the primary. So these non-key attributes are determined by this primary key. So the primary key will identify this is partial dependency. What else functioning on one primary key, the other one? So the product ID. So product ID, order ID there are these partial dependency because these attributes depend only on one part of the combination. So because this whole, maybe I should enlarge this one now. So this whole relation here are basically depending on two primary key, but this relation here are currently functioning on one primary key, and this relation here are functioning on one primary key. So these are basically functioning on one, not on both. So I identify the partial functional dependency. Now what I need to do, I need to map these, show it in the all right. So as we mentioned, product, standard price, product finish, product description are these partial. Okay. The other one is the other one is so the other one is these are functioning on this primary key alone. So this is partial. So now I identify what are the full functional dependency, what are the partial functional dependency in this relation. Going to take this one. You could have only one diagram and show everything, but I'm just breaking it down for you. So now what we need to do, we need to show the relational model that would exist after normalizing this relation to second normal form, then add the second normal form next to each relation name. So in order to do that, you need to either identify the transitive dependency, but if you look into we are working on the second, so we cannot remove the transitive dependency. We can identify them, but let's just do the second normal form, and then we will identify and remove the transition dependencies, and then we will shift it into the third, transfer it into the third normal form. So in order to get into the second normal form, we have to remove the partial functional dependency. So what are the partial functional dependency here? So you got 1, 2. So back into, I'll just copy this one, or yeah, I'll just copy this one and work on it. So what I need to do, I need to remove this partial functional dependency. So I will remove it here. So you break down this relation. So this is one partial functional dependency. So, and then I will remove this one. This is the another partial functional dependency. So by moving this, if I move this now and move this, then only the order quantity will remain. And then if I remove all this, the order quantity will remain with the keys, with the primary keys. So I will keep the product ID and the order ID. So this one will be removed now. So this one also going to be removed. Okay, so what I did now, I removed maybe I'll just place it here. Shift this one down. Okay, so the question is here is we need to show show the relation model that will exist after normalizing this relation to the second normal form. So this is currently in the second normal form because in here you have some transitive dependency which we'll define very soon. So this is the this is the design like now. So this is going to be the primary key here, foreign key here. This one is referencing into that. But what we have here, we have this into, so what I will call this one, I will call it order table. So this is the order relation here. And in this case, this order relation is in the second normal form. If you look into this one actually in the third normal form because it doesn't have any transitive, it doesn't have any other transitive or multivalid attribute. It also doesn't have any partial because it's already been removed. So this is going to be, I'm going to name it order line, and this is going to be in the third normal form. This one also in the third normal form because it doesn't have any transitive. So I'm going to call this product, and this is in the third normal form. Now what we need to do next, identify. So probably I'm just gonna copy this one. just place it with this number 9. So now I want to identify whether there is a transitive or no. And this is can also help you to identify whether it is in the third or second normal form. But this is obvious because you can see customer ID is a transitive because we already discussed that here, that order ID determine this and then determine customer ID, and then customer ID can determine these. So these, the customer name and customer address, are transitive to the order ID because they're actually determined by the customer ID. So what I will actually do, so in order to identify transitive dependency, so it's only occur when A determine B and B determine C and A then determine C. So C does not depend, like if you can see A determine B here, so order ID determine customer ID, customer ID determine customer name or customer address, but customer name and customer address, they are not directly depending on order ID. So this here is going to be a transitive relation. So customer ID, customer, I'm just going to copy this, take it into the transitive question. So as you can see, the order ID, I'm just going to delete this one, I don't need it now. The order ID determine customer ID, okay, and does not determine these directly. Customer order ID then determine customer ID and customer ID determine customer name. It's also determine customer address. So you can do in a separate line or just together. So customer ID, order ID determine customer ID, and then order ID, so A determine B, and A determine B determine C, but C are not directly depending on A. So this relation here called a transitive. So how I will represent that? I will say in this case, okay, and what is else? The customer name also transitive. So these two are basically transitive to order. So this is going to be named as So if we look into, I'm going to copy this now. Okay, so this is the transitive dependency now. And you can see that's why it's in the second normal form. And if we look into the rules for normalization, now we need to remove the transitive dependency. And by removing the transitive dependency, then it will go to the third normal form. So this is what I'm going to do now to finish up our example. So I'm just going to copy these. And then just work it here. Alright, so what I need to do, I need to remove this transitive, these two. Okay, so and according to that, customer ID will determine these. So I'll copy these, put them here, and I'll delete these transitive, and I will keep this foreign key to be able to connect into the primary key. Okay, so this one currently in the so this is currently in the third normal form according to the rules. Alright, so basically we need to, this is customer relation, and it's in the third normal form. This is currently have to be in the third normal form, and this is also in the third normal form, the product. Okay, so now we addressed the last question, the last task. By following these rules. Okay, so show the relation model that will exist after normalizing this relation to the third normal form. Okay, so we are finished with the task. So you can see how we moved from first to second to the third normal form, and we achieved the data normalization. So good luck with your task, and thank you for watching.